Assalamu alaikum students. Now so far we have discussed about amplitude and wavelength. Now as I mentioned, amplitude and loudness are very closely related to each other. Greater the amplitude, greater will be the loudness. So they are directly proportional to each other. So loudness is proportional to the square of amplitude of vibrations that produces sound. So loudness is directly proportional to the square of amplitude. It means if your amplitude gets doubled, then your loudness will becomes 4 times. And if your amplitude becomes 3 times, the loudness will increase 9 times. So loudness is expressed in the unit decibels. During the peak hours of traffic, as you know, different sounds are produced from different vehicles. The loudness at that time is 70 decibels. Now, what is the loudness of sound when we normally speak to each other? Neither when we speak to each other, neither too loud nor too soft. During normal conversation, loudness is around 60 decibels. Now, if you are whispering, loudness becomes half of this, that is 30 decibels. Even breathing also involves sound, which is very soft. So, breathing has loudness of around 10 decibels. Now, next characteristic of the sound wave is frequency. What is frequency? It is the number of oscillations per unit time. Now, what do we mean by that? Let's say you ring the bell. What happens? The metal ball keeps oscillating. So, how many times it oscillated over a particular period of time? That denotes frequency. For instance, let us suppose if it's moving very slow, how do we define one oscillation? So, one oscillation is starting from mean position, then going to one extreme, coming back to the mean position, then going to another extreme, and coming back to its mean position. That is one oscillation. One oscillation from mean position to extreme position, coming back, then going in the other direction, and then coming back. This is one oscillation. So now, say it covers two oscillations in 1 second. If it is moving very fast, then it might cover 20 oscillations in 1 second. So, how many oscillations it is covering in particular period of time? That is called frequency. Let's look at the wave. So, one oscillation starts from here, from the trough, from the point of trough, and completes here from the point of crest. And then from that point to another point, it's second oscillation, and from here it is third oscillation. So how many oscillations it's covering in a particular period of time? It is denoted by nu, and the SI unit of frequency is hertz, after the name of a scientist. Now the next important characteristics is time period. It is the time taken to complete one oscillation. So just now I told you what is one oscillation. So it's from this point to here. So whatever time is taken to complete one oscillation is time period, and it's denoted by capital T, and its SI unit is seconds. Now there is a very close relationship between time period and frequency. If you look at their definition, they are very closely related. Let's try to find out the relationship between frequency and time period. So frequency is equal to 1 by t, 1 by time period. Let's see why is that so. So what is t? T is the time taken to complete one oscillation. Now, how many oscillations are done in t time? One oscillation, so t time is equivalent to number of oscillations in t time is equivalent to 1. Now, how many oscillations are done in 1 second? That is 1 by t oscillations. So, this is unit time, 1 by t, this is the unit time, and number of oscillations in unit time is 1 is unit time, and number of oscillations in unit time is 1 by t. So, this is nothing but frequency, because number of oscillations in unit time is frequency, so it means 1 by t is equal to frequency. Okay, so frequency is nothing but the reciprocal of time period. So this is how frequency and time period are related. Now the next important thing comes, that is pitch of a sound wave. What is pitch? Now the way loudness and amplitude are related to each other, similarly pitch and frequency are related to each other. Now perception of frequency of sound wave. Now as the frequency of sound wave varies, the way sound comes out also varies. So let me give you some examples. Let's look at the example of a guitar and a keyboard. Now the sound coming out from guitar is very different from the sound of keyboard. Similarly, if you take the voice of a female and a female voice is more shriller, whereas the male voice is coarse, rough. Now, why are these differences? These differences are due to the difference in their frequencies. Now, as the frequency changes, pitch of the sound also changes. Now, higher the frequency will have higher pitch, and lower frequency has lower pitch. So, when we say pitch is nothing, so here pitch is nothing but the shrillness in the voice. For example, if you look at female voice has higher pitch as compared to male voice. A male voice has a lower pitch, so male voice is less shrill. So this means the frequency of sound produced by female is higher. Now what do we mean by high frequency? It means it's covering too many oscillations over a period of time. So the waves will be closer together. Like as here you can see in this wave. And if we talk about low frequency, the waves are more spread. It means number of oscillations are less. So high frequency means high pitch and low frequency means low pitch. So objects of different frequencies to produce sounds of so objects of different sizes and conditions vibrate at different frequencies to produce sounds of different pitch. So let's look at low pitch and high pitch sounds. Here you here you can see this is the this has low pitch, low frequency because number of oscillations are less. Low frequency, so therefore it has low pitch. In the second case, it has high frequency because number of oscillations are more, and therefore it has higher pitch. So let's look at some of the examples of sounds around us, and let's compare their pitch and loudness. Now please remember, loudness is always associated with amplitude and pitch is always associated with frequency. Let's take the example of again a male voice and a female voice. So in this case, a female voice has a higher pitch and male voice has a lower pitch. But if you talk about the loudness, male might have the ability to speak louder than a female. But yes, it's not necessary that a sound which is more loud has to have higher pitch, because loudness and pitch are two different things. They are dependent on two different characteristics. Even we can have a sound wave which has higher amplitude but a lower frequency. I will give you an example. Let's suppose we have a wave like this. So this wave has got higher frequency because there are too many oscillations over a particular period of time. But on the other hand, we have a wave like this, second wave, which has a lower frequency because number of oscillations are less. But if you look at the amplitude in the first wave, their frequency is more but amplitude is less because the height of the wave, amplitude is shown by the height of the wave. And here, as amplitude is the maximum displacement on y-axis. So here in the first case, amplitude is less. But in the second case, frequency is less but the amplitude is more, height of the wave is more. So the sound is more loud. So therefore it's very well possible that the sound which is more loud might have a lower pitch. Let's look some more examples. If you compare the sound of a loin and a bird, what do you see? The sound of a bird has a higher pitch. It's more shrill. That is because the frequency is higher. But if you compare the loudness, so in loin the loudness will be more. But it has a lesser pitch. That is because the frequency of sound is less in case of a loin. Even if you take the example of a flute and a drum, the sound of a flute, in case of flute, pitch is more because the sound is very shrill, and in case of drum, it's loud, but shrillness is not there. It's rough, in fact, coarse. So, this is how you can identify the pitch and loudness of various sounds that you will hear around yourself. Thank you.